So good morning everybody, myself Acharya Vishvendra. Today I'm going to discuss a worksheet on surface tension. The first question is surface tension arises due to, it arises due to unbalanced internal intermolecular forces. Second question is on what factors surface tension depends. So it depends on nature of liquid and temperature. Third is surface tension is magnitude of force by length or change in surface energy divided by change in the area. Next is dimension of surface tension. So it is force by length. So we have the dimension as m1 L0 T minus 2. Then we have SI unit of surface tension. So it is Newton per meter or Joule per meter square. Then we have CGS unit of surface tension. So it is either Dyn per centimeter or UG per centimeter square. Then we have ratio of SI and CGS unit of surface tension. So it's 10 is to power 3 as we have calculated over here. Then is a liquid drop of radius r is to be formed. So find external work required. So external work is T into 4 pi r square. Here we have a drop. Then is work required to increase radius from r1 to r2. So work done will be change in the surface energy. So if we take the limit from r1 to r2, that will be T into 4 pi r2 square minus 4 pi r1 square. Next is work done to increase radius from r to nr. So take r2 as nr and r1 as r. So after simplification, we have external work done as T into 4 pi r square multiplied by n square minus 1. Then we have another question that work done in forming a soap bubble of radius r. So a soap bubble has two surfaces. So just double the answer. So we have work done as T into 8 pi r square. And then is work done in increasing radius of soap bubble from r1 to r2. So using the same concept, we put the limit from r1 to r2, and work done will be equal to T into 8 pi r2 square minus r1 square. Then we have another question that work done in increasing radius of soap bubble from r to nr. So that will be like T into 8 pi n square r square minus r square. So after simplification, we have T into 8 pi r square n square minus 1. Then we have another question like we have a sphere and there are pressures are like P1 and P2. So internal pressure P1 minus P2 is equal to the excess pressure, which is 2T by R. So if we draw the graph between Pxs and T, that will be a straight line, and if we calculate the slope angle alpha, so we have tan alpha is P external by T, that will be equal to 2 by R. Then if we draw the graph between Pxs and R, it will be inversely proportional to the radius. So we have a rectangular hyperbolic graph. Then if we have three different graphs like this, so as we can see that Pxs is proportional to the surface tension. So from the graph we can analyze that P3 is less than P2 less than P1. So T3 will be less than T2 less than T1. Then we have a graph of Pxs versus 1 by R. So take 1 by R as x. So the graph will be a straight line. If you have any doubt, you can ask in the comment section. Thank you and have a nice day.